Welcome to the AI Research Roundup. I am Alex. Today we're diving into a paper from the Papers with Code trending list, published April 27th, 2025. It's called Uncertainty Quantification for Language Models, a suite of black box, white box, LLM-Judge, and Ensemble scorers. This research tackles the persistent problem of LLM hallucinations, basically when these models make things up. The authors propose a versatile framework for zero-resource hallucination detection, which means spotting these errors without needing extra labeled data. They adapt various uncertainty quantification techniques. These are ways to measure a model's confidence, transforming them into standardized scores. A key idea is their tunable ensemble approach, which cleverly combines these scores and often works better than individual methods or existing techniques. It's great to see they also released the UQLM Python package for this work. So, this package is all about LLM hallucination detection, using those different uncertainty scorers we just talked about. Inside, you'll find the actual code, installation guides, and some really helpful example notebooks to get you started. Okay, so the paper presents some interesting results. Here shows us the filtered accuracy for Gemini model responses across different confidence score thresholds. Filtered accuracy, in this case, means we're only looking at the accuracy of responses that the uncertainty scorer deems confident above a certain level, or threshold. The x-axis in these plots is that confidence score threshold, and the y-axis is the LLM accuracy. We see different lines for white box, black box, LLM-Judge, and the Ensemble UQ methods plotted across 6 different benchmarks like CSQA, NQOpen, and SVAMP. Generally, as the confidence threshold increases, meaning we only accept answers the model is very sure about, the accuracy of those answers goes up. This is most noticeable for the white box, black box, and Ensemble UQ methods. The LLM-Judge method, shown in red, often doesn't improve much with filtering. Alright, so building on that shifts focus. Instead of filtered accuracy, these bar charts show us the ROCAUC scores for hallucination detection, again for Gemini responses across those same 6 benchmarks, like CSQA and SVAMP. ROCAUC, or Receiver Operating Characteristic Area Under the Curve, is a common way to measure how well a model can distinguish between hallucinated versus correct responses across all possible thresholds. A higher ROCAUC, closer to 1, means better overall performance. We see the LLM-as-a-Judge methods in red, generally at the bottom. In contrast, the black box methods in blue, like normalized semantic negentropy, and white box methods in green, tend to perform much better. And the Ensemble UQ, in purple, consistently ranks at or near the top. It is also clear that the best specific score can vary quite a bit depending on the dataset. Okay, now let's look at this figure presents a similar set of bar charts for the Gemini model responses on the same benchmarks, but this time we're looking at scorer-specific F1 scores. The F1 score is another important metric. It's a way to measure a test's accuracy by considering both precision, which is how many of the items flagged as hallucinations really were hallucinations, and recall, which is how many of the actual hallucinations were found. A higher F1 score, again closer to 1, is better. The trends here largely echo what we saw with the ROCAUC scores. The LLM-as-a-Judge methods, in red, generally have lower F1 scores. In contrast, the black box methods in blue and white box methods in green perform significantly better. And once again, the Ensemble UQ method, shown in purple, is consistently a top performer, often ranking first or second across these different datasets. This reinforces that the ensemble approach is quite robust. Wrapping up our look at this paper on uncertainty quantification for language models, it's clear that having robust methods to gauge LLM confidence is really crucial. A key takeaway for me is how effective the Ensemble UQ methods are, consistently outperforming individual scorers and particularly the LLM-as-a-Judge approaches. This kind of research is vital for building more reliable and trustworthy LLMs. Thanks for tuning in to the AI Research Roundup. I'm Alex, and I'll catch you next time.